So today another hard problem because I have time for it. My calendar free. A K booking happens when K events have some non-empty intersection. You are given some events, so return maximum K booking between all. Okay, that's interesting. So the times are 10 to 9 and there will be at most 400 calls to book. Only 400 calls? That seems rather easy, don't you think? Because for 400 you can basically do anything. I can do n cubed for that matter. What the hell? I mean, I can solve it in let's say we have q queries. I can solve it in q squared easily. What the hell, bruh? So we can just do sweep line, but that is ridiculous, bruh. Can you answer the queries faster, maybe in logarithmic time? Because if you add id, what happens? I mean, with a lazy segtree, I could solve it in log q, I guess, but lazy segtree is probably not a codable thing in in an interview. I'm not that good right now that I could barely shit out segtree, let alone lazy segtree. I mean, you would need the propagation, but with lazy segtree, I couldn't do lazy segtree. No, I couldn't. If we would have the queries, we could compress the coordinates, and then since there is 400 calls, the coordinates will be small and we are done. But this probably is supposed to be online, so I cannot even use the lazy segtree. Okay, I mean, let's do the simple events vector. I don't know, let's do event, and there will just be a pair of int events. I don't need technically anything, I guess. Events clear, maybe. Events push back start time 1, events push back end time 0. What is das and time plus 1? So we are making a timeline of events, and we go as the time progresses, and at start position we have an opening, and at end plus 1, imagine we put it on a line, and at each position of the event we add a plus 1. And this is what it essentially does, is that it puts a plus 1 at the start and minus 1 after it ends. So if you would do prefix sums, then it would exactly match that plus 1 in that sequence and then zeros. And this is the second parameter is necessary to know if it's opening or closing event. And closing events have 0 because we want to first close the events, because let's say we have from 5 to 10 and from 11 to 15. Then if we would process starting first, then we would first process the start of 11:15, and it would be, we have 2 intervals. But if we process the end first, then we first decrease the number of intervals, right? Because we have the ending event for 5:10, and then we start a new interval. So I mean, that's it. Events, sort events, begin events, and we don't need a custom comparator because pairs can be compared. And now after we done that, we do a simple sweep. So maximum, max k, and this will be current k, and then we go through events for auto events, and then we don't care about the time really. So what we want to do is current k plus equals event 1, so it's a start, then we do 1, otherwise it's -1, and max k, max k current k, and finally return max k. I think this should work. First that is weird. Key first. Let's check this. It should be second, not first. That is weird. So first we have start 10 and the 21. I mean, that's obvious. Still 1. Then we have 2 events. Yeah, at most. Then we have 3 events immediately. Why is this not 4? Oh, okay, because we are given all half open intervals. Okay. I mean, unless I'm missing something, this should pass immediately. It's very slow. Interesting. Let's see editorial. Sweep line algorithm, n squared. Of course, but who is doing a segment tree, bro? Who is doing a segment? What the hell is that? That's actually extremely simple. What? What the hell? Proof is not easy, so we ignore it. I mean, holy tree, what is that? That is weird. So you update start end with 1 and and lazy plus maximum of those. What? Okay, I didn't think you could combine that. Interesting. That is interesting. Okay, let's write the tutorial and then I will look at those solutions, but that's... Or should I? Let's read this and try to have multiple. Wow. Days. If we use an array vals with length 1 in 9, okay, I got to that, but L and R are the endpoints. Val is the number of events. What is that? I mean, I'm not that proficient in lazy segmentaries. I don't think I needed it a single time in a competition. Maybe I'm just bad. That's not very likely, but okay, so left, right, who cares? Okay, algorithm. Okay. Will you update those nodes recursively? I mean, oh, you just explained the implementation, but what is vals? You never said what is. Okay. So if is the interval, so left right is the interval, so if it's inside you just update lazy and vals, otherwise you update left right and then vals is lazy of that index plus max of vals. Okay, I would never in my life do this, and unordered map is slow, but okay, that is interesting. I would never think it's that easy. Okay, so let's just look at this, and so let's start with unordered map int lazy vals. We don't need this, I think, at all. Maybe we do. I don't know, bruh. Hell nah. We don't need this, and it should be in private. Public. Book will run a return query, or maybe not. Why vals 1? Oh, okay. Return vals 1, update start time and time 1 in 9, and update with value 1, void update, or that is index. Oh, that's index. Okay, so int start, int end. I think it was called different. So from how I know it, it's like this. Start with 1. We go from 1 to 1 in 9, and our range is start and end. I know it like this. And now if lux over r, or lux under l, return if lux larger than or equal to l, lux and rux smaller or equal to r, lazy x vals x in the mid lux, let's call it mux is update 2 times x plus 1 update max right left right, and finally vals at x is lazy at x plus maximum of vals 2 times x plus 1 and vals 2 times x plus 2. So I got the idea, but I just didn't know that it can be implemented this way. That's actually extremely easy, I guess. And I'm not sure how you got an overflow on this, but okay. How you got to this number, dude? How? What the hell? Salt x. My messenger is popping off. I'm not sure how you got to this, to be honest. Did I do it right? Start end is my LR, so start end index times 2. I mean, it should work now. Still it doesn't. It's gonna just go to infinity or what? Bruh, what the hell? How is it possible? Ten 19 1. So you go away into this range. Are you sure it really should be long long? Because this is not using long long, and it should work apparently. It still doesn't work. Are you shitting me? What's the problem, dude? How is it that my interval is, so I'm inside 9 10 and 1 15, so then you go into 8 15. Why would you do that exactly? I think because of this. Okay, now it passes. I would never. What the hell? That is crazy. You can just do a lazy segtree with max and update. What? That is insane, dude. Holy. That is crazy good. That's awesome. Okay, I will submit these two so that I get that is slower. That is slower because of the unordered map. I mean, but that's a good way to think about it. Okay, and what about this last one? So split the interval. I mean, isn't it the same basically? So start x is minus upper bound start upper bound x second split, split start, split end. What the hell? That is crazy. Why would you use a hash map? Okay, so my solution is actually slow, extremely. Let's see. I need submissions. So let's see, segmentary, JavaScript, clean code. Whatever. Let's try optimize my approach. Can I get the code from this? Copy to editor. Okay. So I mean, I use kind of inefficient structure, I guess. So I don't need this at all. And then we wanna do event start time plus plus events end time minus minus. Then we don't have to do this. Oh, why this not work again? Wait. Like this. So delta. Okay, will this be faster? This was 364. This is 49 milliseconds. Okay. Interesting. Okay, fair enough. Okay. I mean, my solution was not linear. I was sorting, so I was n squared log n. Okay, whatever. Let's change this to private, make this public, and then submit once again. Runtime 49, runtime 21. Okay. Can we speed this up? If I use const auto unmodified values. 21 milliseconds. 41. Okay, that's slower. Let's do it with okay, 43, and with auto 50. So it was just a coincidence that I got 9. Okay, so it doesn't matter at all. Fair enough. Okay, so let's read about the last approach. Okay. Book a new event, binary search all starting points. But then what? This is so bad. Why would you do it? You are going through the entire tree, bro. What the hell? Why would you do that? I mean, I understand you are just keeping the trees, but that is stupid slow, dude. I mean, in the last iteration you are gonna run in ON time, bruh. What do you mean? Okay, I mean you just maintain the intervals. Book event. Binary search starting points to find LR such that so you find all intervals that overlap with this one. L1 start and start R1, keep the events in them same as the original interval. Keep the events in them the same as the original and put them back in binary search to get first. So between this and what that means inclusively. Increase the events of them by 1 as we edit a new event in time. This is stupid, absolutely. I like this, but this is just bad. Okay, let's do a submission. Whatever. Let's do not notes, but let's open the submission. Thanks. And let's write the solution. So sweep line intuition. Keep the events ordered and for each there will only be 400 queries, therefore we can just keep the events, we can just sort the events when a sort each time a new event comes, each time a new, don't call it event, new booking comes, make a sweep line over the already placed bookings approach. we can sort the events for each opening if we treat start time as an opening event and end time as a closing event. We can sort the events by time and keep the current number of bookings when we encounter start time, when we encounter a start time instance, a start of a booking, we increase the counter by 1, else we decrease it by 1. It's important to give and to give bigger priority to booking and events. Otherwise we can get a wrong answer if the bookings are consecutive. N squared log n, where n is the number of bookings. Note that we can speed this up by using a ordered map. We add to O of n squared O of n log n per query, O of n per query, note that we can speed this up by using an ordered map. This solution would update start time with +1 and end time with -1 in the ordered map, and then we would just because you to go for no, you cannot speed it up with a map. No, okay, so actually I got a decent solution. Note that you can use an ordered map to achieve the same time complexity. or a lazy segment tree with a hash map to achieve all log C time per query, where C is the maximum time. Okay, space complexity of n, since we store all bookings. Okay, so complexity. Note that remark okay, so let's post it. That's enough for today. I got stuff to do. I mean, honestly, I expect it to be harder, but yeah, whatever. Goodbye.